Introduction to the most recent discoveries made under Geneva's shadow. Beneath the surface of our world exists a masterpiece of human imagination, and a potential catalyst for destruction. This is the Large Hadron Collider, LHC, an unparalleled instrument for experts, enabling them to conduct research into subatomic particles and discover the mysterious God particle. Brian Cox, a renowned physicist from the Higgs boson research team, has provided a frightful explanation that has sparked conflicting feelings among scientists. He urges them to investigate the fundamental parts of reality and examine spacetime's very essence in detail, despite the immense effort required. Additionally, these experiments present significant dangers, both known and unknown. One of the most pressing issues surrounding the LHC is the possibility that this massive collider could produce tiny black holes or other extraordinary events. Theoretical outcomes are unpredictable. According to models, any such black holes would be brief and not pose danger to Earth or its inhabitants. However, the vulnerability to accidentally creating horrors beyond our control remains unsettling. The vast scope and complexity of the experiments carried out at the collider require strict safety protocols and supervision to reduce potential threats. The international group of scientists and researchers involved in the collider's operation is keenly aware of the necessity to prioritize safety and ensure that all experiments are conducted with the utmost caution. The Large Hadron Collider, with its capacity to awe and challenge our perception of the universe, is more than just a modern triumph of engineering. It is also an important hub of contemporary particle physics and cosmology. Its primary objective is to investigate the basic particles that make up the universe, carrying significant repercussions for our understanding of existence. The LHC enables scientists to reproduce conditions immediately following the Big Bang, presenting an extraordinary opportunity to investigate the Higgs boson and other fundamental particles. Frequently referred to as the God particle, the Higgs boson was postulated in 1964 by Peter Higgs and his colleagues as a crucial component of the Standard Model of particle physics. This model defines the fundamental forces and elements of matter that make up the universe. The identification of the Higgs boson in 2012 at the LHC confirmed the existence of the invisible field that gives other particles their mass. This finding was a significant accomplishment, proving decades of theory and deepening our understanding of the universe's structure. However, as with all major scientific investigations, the search for knowledge at the LHC is not without ethical dilemmas and potential dangers. The energies generated when particles collide at the LHC are mind-boggling, and the potential for the development of novel forms of matter, or even initiating unexpected reactions, cannot be completely ruled out. Rumors among scientists speculate that high-energy collisions could result in the formation of small black holes or suspicious, exotic particles. While the majority of experts consider these dangers to be extremely remote, the very essence of scientific inquiry necessitates taking risks. Brian Cox's assertion about the unknown brings up the possibility of creating a miniature Big Bang within the LHC, emphasizing the enormous significance and potential threats of this investigation. Despite its remarkable capabilities, the LHC also sparks fundamental debates about the responsibilities and limitations of scientific research. Through its design and operation, the LHC seeks to answer fundamental questions about the universe. But it operates at the very margins of human comprehension, and this level of technological proficiency raises significant questions regarding the nature of science, ethical dilemmas, and the potential consequences of cutting-edge research. One of the most thrilling aspects of the LHC is its ability to recreate conditions immediately following the Big Bang. This replication allows scientists to examine the particles that existed during the universe's earliest phases and to investigate phenomena that would otherwise be difficult to access. By bringing these extreme conditions back to life, researchers can evaluate theories and refine models, for instance, in particle physics. The LHC experiments have the ability to examine the properties of speculative particles such as dark matter, which is thought to make up a significant proportion of the universe's mass. Although direct detection remains difficult, the pursuit of understanding dark matter carries profound implications for our knowledge of the cosmos. Currently, the existence of dark matter is inferred from its gravitational effects on visible matter. The LHC aims to address this issue by attempting to produce dark matter particles in the laboratory. If successful, this could revolutionize our comprehension of the universe and lead to transformative discoveries. These insights highlight the LHC's role not just as a scientific instrument, but as a driver of revolutionary breakthroughs that may change our worldview. An enticing field of inquiry involves the strong nuclear force, one of nature's 4 basic forces. This force binds neutrons and protons in atomic nuclei. Understanding its behavior at elevated energies offers valuable insights into the fundamental structure of matter. The LHC's ability to probe extreme interactions between forces enables researchers to investigate the dynamics between gluons and quarks, fundamental elements responsible for the strong force. These investigations may lead to a deeper understanding of nuclear physics and the forces that govern atomic behavior. Beyond the realm of particle physics, the LHC has had a far-reaching impact on technological progress. Its intricate systems for detecting and analyzing particle collisions have inspired innovations in data processing, analysis, and sensor technologies. For example, the World Wide Web was initially developed as a way for CERN researchers to share data from particle physics experiments. Today, this technology has transformed global communication and information sharing. The LHC's influence on data management has affected diverse industries, demonstrating how foundational scientific research can spur technological development. However, operating such a powerful instrument requires strict safety measures and careful ethical consideration. The potential for unanticipated outcomes, like the emergence of novel or exotic particles, necessitates rigorous risk assessment. Even though theoretical models suggest that catastrophic scenarios are extremely unlikely, the possibility cannot be completely dismissed. This underscores the importance of conducting research with caution, transparency, and public engagement. Informing the public and involving them in discussions about risks and mitigation strategies is a critical part of responsible scientific research. The LHC has generated a strong desire for dialogue, emphasizing the need to communicate complex scientific ideas to a broader audience. Effective science communication demystifies research and encourages informed public discourse about the implications and risks of advanced experiments. By maintaining open communication with the public, researchers can address concerns, dispel myths, and build trust in the scientific process. As the LHC continues to operate and the likelihood of new discoveries grows, vital questions emerge. As research at the LHC advances, new experimental phases are being prepared, including upgrades to increase collision energy and improve detector sensitivity. These enhancements are designed to push the boundaries even further, allowing scientists to probe deeper into unknown realms of physics, such as supersymmetry, extra dimensions, and the unification of forces. Supersymmetry, or SUSY, is a theoretical framework that suggests every known particle has a heavier superpartner. While no such particles have yet been confirmed, their discovery could resolve many inconsistencies within the standard model and provide insight into the nature of dark matter. If supersymmetric particles were to be detected, it would mark one of the most profound scientific shifts since quantum mechanics. Moreover, the possibility of uncovering extra dimensions, predicted by string theory and other advanced models, raises philosophical as well as scientific questions. If dimensions beyond the familiar three of space and one of time exist, they could offer explanations for gravity's relative weakness or for the apparent fine-tuning of the universe's constants. Yet, with each leap forward, the LHC serves as a reminder of science's dual nature, the capacity for both illumination and risk. The very act of smashing particles together at near-light speeds opens the door not only to understanding the origin of mass or the evolution of the cosmos but also to phenomena we may not yet comprehend. In public discourse, the LHC has become a symbol of humanity's ambition and curiosity. It draws admiration for its sheer scale and audacity, yet it also provokes concern about whether we are venturing into territories we are ill-prepared to manage. These fears are not without precedent. Many of the greatest discoveries in history, from nuclear fission to genetic modification, have carried both promise and peril. This is why governance, transparency, and interdisciplinary dialogue are essential components of such a monumental endeavor. Scientists are not alone in this journey. Ethicists, philosophers, policymakers, educators, and the public must all play a role in shaping how such knowledge is pursued and applied. Education, in particular, is crucial. By fostering scientific literacy, we enable the next generation to engage meaningfully with discoveries of this magnitude, not with fear, but with informed curiosity. As the LHC continues its search for the building blocks of reality, it also challenges us to build a society capable of responsibly interpreting and applying its findings. In many ways, the Large Hadron Collider is not just a machine buried beneath the Earth, it is a mirror, reflecting both our technological prowess and the deeper questions we continue to ask about existence itself. What is the universe made of? Where did it come from? Are we alone in its vast expanse? And how far are we willing to go to find the answers? The story of the LHC is far from over. With every collision, every particle tracked, and every anomaly detected, we inch closer to unlocking the ultimate truths of our reality. with repercussions that go beyond our current knowledge. Before looking into the effects that Cox's assertion has, it is important to know how the CERN's Large Hadron Collider, LHC, is in operation. The LHC is a 17-meter superconducting loop, the most potent particle and magnet accelerator ever built. It represents the highest level of human achievement, capable of establishing conditions for the historic beginning of the universe. This apparatus grants us access to shedding light on the cosmos mysteries, something truly revolutionary, and CERN's potential for change. Constructed in the year 1954, CERN is one of the most prestigious research establishments, consisting of 23 states and a large network of scientists. The LHC, though a major initiative, is only one component of a larger system of exploring accelerators and detectors. The LHC's acceleration of protons at speeds close to the speed of light replicates the energy state at the moment of the Big Bang and what followed. Collisions produce millions of degrees Celsius, times as hot as the core of the Sun, using a complex collection of magnets that direct the protons on their journey. The magnets are maintained by cooling systems at temperatures lower than those of space. The LHC's design is an engineering marvel, operating deep below the surface and protected from cosmic rays. The entire ring is brought down to a temperature below those of the vacuum of space, which is necessary for superconductivity to function effectively. There are collisions at 4 points along the corresponding accelerator rings, each connected to one of the 4 principal particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors record the effects of collisions, allowing scientists to sort through the debris in search of the elusive peaks, crucial elements for comprehending the LHC's understanding of the universe's structure. As an instrument of science, the LHC is also a testament to human creativity and ambition, exemplifying our desire to comprehend and understand the fundamental factors that determine our universe. Nonetheless, as we test the limits of understanding, it is essential to take into account the questions about morality and existence that emerge. The desire to recreate conditions akin to those of the Big Bang carries significant responsibilities. Likewise, the pursuit of knowledge should never compromise the safety of the public. The process of scientific discovery frequently includes moments of wonder and awe, and the LHC, or the Large Hadron Collider, serves as evidence of humanity's unwavering curiosity and the compulsion to discover the most buried treasures of the universe. Despite its enormous potential to reveal the nature of matter, the LHC also calls for balance, the harmony between caution and investigation. As we delve deeper into the world of the microscopic, the LHC is not merely a marvel of engineering but a symbol of the intricate connection between science and society's vision. This encompasses the ongoing efforts, beyond the LHC, to discover the undiscovered realms of physics, such as the search for a unified theory of everything. While particles are the focus of studies at unimaginable energy levels, the objective is still to answer some of the most fundamental inquiries. What was the beginning of the universe like? What fundamental forces control everything? Even if there are other dimensions, these are questions about existence. Despite the theoretical push, humanity's limitations in science have never been higher, allowing us to fantasize about solutions that once appeared out of reach. Despite these advancements, the scientific community must always deal with ethical issues. A significant problem is making sure that the LHC's discoveries are used ethically. With such revolutionary potential comes an obligation to ensure that the information gleaned from these experiments does not unintentionally harm or result in unanticipated consequences. As new particles or interactions are uncovered, it is crucial that their repercussions are taken into account fully, and that global frameworks for governance are in place to guide the application of this information. The findings of the LHC may have profound effects on areas beyond physics, including energy, medicine, and technological advancements. For instance, accelerator technology has the potential to offer better options for cancer treatment, while the ability to comprehend fundamental particles can aid scientists in developing more effective energy systems. Collaboration in energy systems plays a crucial role in the LHC's future. The project entails a worldwide network of engineers, scientists, and researchers from various disciplines and backgrounds. This spirit of cooperation is essential for the continued success of the LHC and addressing the issues it presents. In the future, it will become increasingly significant to foster scientific cooperation among nations. The exploration of the LHC shows how advancement is possible when nations cooperate, sharing information for the benefit of humanity, transcending political and geographical boundaries. In an environment where scientific discovery frequently occurs at the intersection of disciplines, the exchange of knowledge and ideas is essential for progress. The LHC's contribution to the development of knowledge about the universe is profound, but it is just one component of a larger vision. Imagine the experiments carried out at CERN as setting the stage for future generations of researchers to examine the next step in comprehending the forces of nature. While the LHC continues to operate and new discoveries are made, it will shape the science of the future and continue to alter our perceptions of the world. As we are on the cusp of cutting-edge scientific frontiers, it is essential to keep in mind that our investigation should go beyond mere respect, but also understanding the ethical considerations associated with wielding such power. The questions we answer today may change the world for generations to come. At the end of the day, the Large Hadron Collider is the pinnacle of human scientific achievement, investigating its enormous potential to discover the secrets of the universe. However, this is matched by the substantial risks associated with its operation. As researchers go deeper into the fabric of reality, vigilance will continue to ensure that the search for understanding is achieved with the utmost care and responsibility. As we are on the verge of discovering the unknown, the question remains, are we ready to accept the forces that are about to be unleashed? As we stand at the threshold of such monumental discovery, the ethical implications of this research become ever more pressing. The LHC's experiments hold the potential to unlock secrets that could redefine our understanding of the universe and challenge our current conceptions of physics, reality, and existence. Yet, with this power comes the responsibility to ensure that these advancements are pursued with careful consideration of their broader impacts, both immediate and long-term. The pursuit of knowledge is not without its risks, and as scientists and researchers push the boundaries of what we know, they must navigate the delicate balance between curiosity and caution. The consequences of the LHC's discoveries, while promising in terms of technological advancements, could also have unintended effects on our world. What will we do if the results of these experiments reveal truths that shake the very foundation of what we understand about life, the universe, and everything within it? As we continue to explore the unknown, the key to ensuring that these efforts are beneficial lies in fostering a global dialogue about the ethical considerations of scientific progress. This dialogue must be inclusive, involving not just scientists but ethicists, policymakers, and the public at large. Only by considering a diversity of perspectives can we ensure that the discoveries made through the LHC and other scientific endeavors are used responsibly. The search for the fundamental truths of the universe cannot, and should not, come at the expense of the values that define us as a species. The very nature of science is to question, to challenge, and to explore, but it is also crucial that we remain grounded in our shared human responsibility to safeguard the well-being of all people and the planet itself. In the end, the LHC represents much more than just an experiment in particle physics. It is a symbol of humanity's unyielding desire to understand the universe, to push the limits of possibility, and to unravel the mysteries that have eluded us for centuries. But it is also a reminder of the power and potential dangers that come with such knowledge. The journey ahead is one of discovery, but also one of wisdom, as we must ensure that we are prepared to handle the truths we uncover. As we stand on the cusp of what may be the greatest scientific revelations in human history, we must ask ourselves, are we ready for the responsibility that comes with this newfound understanding? Are we prepared to face the profound questions that the LHC and its discoveries may bring, and to handle the consequences, both expected and unexpected, that may follow? The answers to these questions will shape the future of science, humanity, and our place in the universe. It is a future that will be determined not only by the discoveries we make, but by how we choose to use and understand the knowledge we gain. The LHC is not just a testament to human achievement in science, it is a reminder that with great power comes great responsibility, and that our journey into the unknown must always be tempered by caution, care, and ethical responsibility.